in vertex form. So we get 2 is going to be a vertical stretch. Going to multiply all those changes by 2. Minus 3 goes to the right 3. Opposite of how we think about it. It's with the x, and so it does everything opposite, left and right. Plus 1, not with the x, and it's also not with the y on this case, so it does everything up and down, but exactly how we think about it. So left 3, up 1. Vertex 3, 1. Axis of symmetry, I'm going to say AOS, x equals 3. It's going right through the middle there. And we go 1 squared is, but it's the vertical stretch. So 1 squared is 1, but then I'm doubling it. 2 squared is 4. 1, 2, 3, 4, 5, 6, 7, 8. So we're there. Now, the y-intercept, again, is not as easy to find. It's very tempting to say the y-intercept is that plus 1, but remember that's the vertex. So plug in 0 for x. Y-intercept. X equals 0. So 0 minus 3 is negative 3. So negative 3 squared is 9. Times 2 is 18 plus 1, so 19. Y-intercept is 0, 19. Alright. 3x squared minus 6x plus 1. This is in standard form. Again, the benefit of standard form was that the y-intercept was really easy to find. The y-intercept, again, where x equals 0 because you haven't gone left or right. 0, 0, 0, comma 1. Very easy to find. Vertex. First I'm going to find the axis of symmetry, which is negative b over 2a. That is something you need to know. I'm going to show you where this comes from later on this chapter. So a negative 6. Be careful of that. So really positive 6 divided by 2 times 3. So 6 divided by 6 is 1. And if I plug it back in, 3 times 1 squared minus 6 times 1 plus 1. 1 squared is 1 times 3. 3 minus 6 plus 1. Negative 3. Negative 2. So the vertex is 1, negative 2. And so the axis of symmetry was 1. And we have axis of symmetry, so we can reflect this over. Notice how this makes sense. We've gone left and right 1, and 1 squared is 1, but we multiplied it by 3 because that a out front. This a does the same thing in every single form. It will be the same number in every single form. If we go left and right 2, 2 squared is 4. 4 times 3 is 12. So up 1, 2, and then up to the 10, and it reflects. So there's your graph. So it obeys that same general rule. Find the vertex, and then you can find the rest of the points. And you may have some of them anyways. So this is factored form, so it's intercepts. The x-intercept is very easy to find in this case. Y equals 0. So 3, 4. X minus 4 equals 0. X equals 4. X minus 3 equals 0. X equals 3. So those are our two x-intercepts. Our axis of symmetry has to be right in the middle of those two. So what that means, you have 4 plus 3 divided by 2, 7 halves, or 3.5, which makes sense because that's right in the middle. You could have eyeballed that. You didn't have to do this. I just wanted to show you what I meant by average x-intercepts. So, and then the vertex is when you plug it back in, y equals 3.5 minus 4, 3.5 minus 3. So that's negative negative 1/2 times a positive 1/2. So ultimately, a negative times a negative is going to be a positive 1/4. The vertex is 3.5, comma 0.25, 1/4, 0.25, 3.5. Okay, so that's where we are. 0.25. The y-intercept. Plug in 0 for x. Negative 4. Actually, let's say 0 minus 4, 0 minus 3. So that's negative 4 times negative 3 is positive 12, made negative, so that's negative 12. So we're down here. And then you could reflect that over. 1, 2, 3.5. Half, 1, 2, 3. Alright, so let's practice one more thing. I want you to know how to find a min or max on your calculator. And so let's stick in 3x squared minus 6x plus 1. 3x squared minus 6x plus 1. Remember the x button's right here. And so we graph it. So we should get something similar to what we had drawn, and we do. And if you hit the second and the trace button, second and then trace, it'll get you to minimum and maximum. Because ours goes like this, we have a minimum, gets the lowest value. Now it's going to give you left bound and right bound. You're going to tell the calculator this is left bound and this is right bound. You have to tell the calculator where to look. It's not smart enough. And so it's going to look to see where is it at its lowest value and zoom in on it basically. So here's our minimum. I'm going to go to the left and then go to the right. Hit enter to get to the next one. Now it says guess. Some people like to scroll back down, but you don't have to. Just hit enter. And we get 1.000023. Remember, it's approximating. So that's about 1, as close as you can get to 1, negative 2. And that's what we got before. So again, what we did was type it into y equals, and then second trace, which is the calc menu, minimum or maximum. And that is as thorough as you can get with graphing